we want to be able to describe the motion of an object using a velocity versus time graph, okay? So there's a lot of stuff going on here, so we'll just go through each of them and see what's happening. But here, if you'll notice, the velocity at the start is 0, all right? So it's at time 0, the velocity is 0. So this starts at rest, okay? We're not moving, okay? Now this is kind of tricky because you're like, all right, my velocity is getting more negative, right? I'm at -2, -4. I'm just making up numbers here. It could be anything, but let's say these were my velocities, okay? Now you have to be careful with velocity because velocity is just speed with direction. So right here, I'm at 2 meters per second. It is negative, but the speed is 2 meters per second. And then I'm at 4, 6, 8, 10. So as I'm going away, as time is growing, right, 1, 2, 3, 4, 5, 6 seconds or whatever it is, as I'm doing that, I'm actually speeding up, right? So this is actually speeding up. And what's happening is I am going in the opposite direction of whatever the positive direction is. So the negatives, all right, so this negative part here means the opposite direction of whatever my positive is. So if I would consider the positive direction to the right, then I would say I'm speeding up to the left. Okay, now let's go back to this speeding up here. All right, the way to speed up is you are going to be moving away from the v equals 0. So this is v equals 0 along the x-axis. So if I'm moving up, I'm speeding up, and if I'm moving down, I'm speeding up. So the way to speed up is to move away from the x-axis, or this, you know, this axis right here. You want to move away from it in order to speed up, which means if you are moving toward it, you are slowing down, and then once you hit this, then you're actually stopped. Okay, so speeding up, you're moving away from the x-axis on a velocity time graph. All right, for B, if you'll notice here, I have 0 velocity. Here I have 0. Here I have 0. So my speed, not only is it not changing, but it's also equal to 0. So v equals 0, which means I'm at rest the whole time in this diagram, okay? Now if we're looking over to this one, right, my velocity is also not changing. The difference between this one and this one, though, is I actually have velocity. So let's say this was like 4, right, 4 meters per second, 4 meters per second, 4 meters per second. So I'm continually moving. So I am increasing my distance, right? It's just I'm going at a constant pace. So I'm just walking at a constant rate, or at 4 meters per second, you'd probably be jogging or running at that point. So this is constant velocity. And the other thing I want to point out is this is a positive 4. That means we're moving in the positive direction. So if I'm thinking like left and right for positive, negative, then I would say not only is it constant velocity, but it is to the right. So constant velocity to the right. Okay. Here, if I kind of follow this line, I'm starting here. So I have some initial velocity. I don't know what that is. Maybe it's like a 2 if I just put a random number on there. But I have some initial velocity. So I'm not starting at rest. I'm starting with some value. And then I'm moving away from the x-axis. The further away you get, the more you are speeding up. So I am speeding up. Okay. In the, or I could say just like I'm speeding up to the right. Okay. So the only other thing I think that we really could add to all of these, again, as you notice, none of them are going to this axis, but if I were getting closer to this axis, it's like I'm getting closer to v equals 0, so I'm slowing down as I get closer to this. The other thing is, if I am speeding up, if that's happening, that also means that I am accelerating, okay? So right here, this would be a positive acceleration, okay? Because I'm speeding up and I'm going to the right. Now, what's funny about this, though, is if I come over here, I'm speeding up, right? This is actually a negative acceleration. Okay, so this is a great example of showing how you have negative acceleration even if you're speeding up. All right, acceleration is also a vector quantity, so you have negative acceleration. If you're speeding up in the opposite direction, that's also going to give you negative acceleration. That's not the same thing as decelerating. All it means is I have a positive velocity in the negative direction. Here, I have a positive velocity in the positive direction, so I have a positive acceleration. Then for goal 28, we want to know what it means by free fall. All right, so the velocity of an object in free fall increases with time. Is that true or false? Okay, so if you're free falling, you start here. Let's say you have this object. You start at 0. All right, now if you guys remember, the acceleration due to gravity is about 10 meters per second. So after 1 second, I'm going to be 10 meters away. Okay, but I'm accelerating by that amount. So after 2 seconds, right, then I'm falling and I'm 20, all right, meters away. So I'm increasing, I'm accelerating as I go down, which means the velocity is increasing. I'm actually getting faster and faster because I was only going 10 meters per second here, but here I'm going 20 meters per second because this is 2 seconds now at this point. So the velocity of an object in free fall does increase with time. I'm getting faster and faster each second. All right. The acceleration of an object in free fall does not change. That is also true. Velocity changes. It is increasing by 10 meters per second every second. The acceleration of an object is represented by g, and that's 10 meters per second squared, and that number does not change. You could have a different number if you were on like a different planet or the moon. It might not be the number 10, right? But that number there also would not change. So anything in free fall, the number is not going to change. The acceleration is not. The force that causes free fall is your gravity force. So force due to gravity. And the acceleration of an object in free fall, again, that is a constant number. Okay, and that is g equals 10 meters per second squared. That does not change.